So in question 5, we have a rod with a sphere attached to the end of it, connected to a horizontal axle, and it can rest in the vertical position. And then we're told that the sphere is lightly tapped from this vertical position. So we can see this in frame A, so that it is made to rotate around the axis. We're told that the student takes a video of the rod rotating from the vertically upward position to the vertically downward position, and we have these 5 frames, and we need to answer in part A 2 questions about these frames. So in the first question, we are asked, in which frame is the angular acceleration of the rod sphere system the greatest? So what we know is that torque is equal to the moment of inertia times the acceleration. So we need to see where is the torque the largest, because the moment of inertia is the constant. So the torque is simply the force times the distance. And well, the force is going to be the weight of the sphere. And so we can draw the weight into all of these diagrams as a downwards pointing arrow. And we need to see when this has the largest arm with respect to the axis. So all we need to do is draw this dashed line, elongating the vector's direction. And we need to see when is the distance between this dashed line and the axis the greatest. So we can see, for example, in frame A and in frame E, the distance is 0, so they're on the axis, meaning they do have no torque. Whereas in B, C, and D, they're not on the axis, so there is some non-zero distance. However, it is very clear that in frame C, the distance is the largest. And therefore, the torque in frame C will be the largest, and therefore our acceleration will also be the largest in frame C. And yes, so we can say the lever of the arm is greatest. And then in part 2, we're asked in which frame is the rotational kinetic energy of the rod sphere system the greatest. We need to briefly justify it. Well, it will be frame E, so when it's completely down at the vertical down position. And well, for example, this is when the most work has been done on the system. So most work done by gravity. As we can see that throughout these 5 frames, it is always accelerating. So as it goes lower and lower, it's always accelerating all the way up until this point, and then afterwards it would start decelerating again.